everybody, and once again, welcome aboard this E-ship. I'm Hugh Palermo. The flight time will be 2 hours.
Our flight time will be 5 hours and 24 minutes.
Welcome back to Plain and Simple, the Clean Aviation podcast. In our last episode, we spoke about the Pharos and Osiris projects. Today, we are exploring the anatomy of something equally ambitious, the ultra-efficient regional aircraft. But what does it take to build a regional aircraft that is not only cleaner and quieter, but also ready for real-world certification? The answer lies in two complementary projects, HERACLES and DEMETRA. Together, they form a coordinated cluster of 4 initiatives tackling everything from propulsion and electrical architectures to full-scale system integration, all within the Clean Aviation framework. To make things easier to understand, imagine the airplane like a human body. The Pharos project represents the engine or the heart. The Osiris project represents the systems or the nerves. HERACLES, on the other hand, is like the brain, making decisions and ensuring that the airplane is ready for flight testing, while DEMETRA is similar to the flight test airplane, bringing together the parts to create an airplane that can soar across the skies safely and sustainably. These projects are designed to push hybrid electric technologies to maturity, proving that sustainability and regional connectivity go hand in hand. Today, we're joined by 2 guests who will help us unpack the complexity behind this vision. Alessandro Sguea, Project Coordinator for HERACLES, and Laure Dupire, Project Coordinator for DEMETRA. Both are part of ATR, which stands for Avion de Transport Régional, the top regional aircraft manufacturer. Hello and welcome to you, Alessandro and Laure.
Hello, everybody.
Hello. Alessandro, let's start with HERACLES, which acts like the brain. Can you give us an overview of the project and why it is important?
Of course, it would be a pleasure. And to answer this question, let's first start with what is the acronym of HERACLES, which stands for Hybrid Electric Regional Aircraft for Low Emissions. And actually, if you see it, the objective of the project is in the name itself. Precisely, HERACLES aims to define and study a new concept, what we call the ultra-efficient regional aircraft, or abbreviated UERA, which is a future aircraft concept capable of reducing the CO2 emission by 30% compared with our ATR 72-600, with the target entering into service there is 2035. By itself, HERACLES does not develop individual technologies. Instead, it acts as the aircraft integrator, like you say, the brain, coordinating multiple clean aviation projects, each one focusing on specific innovation, like hybrid electric propulsion that you already seen in our last podcast from Pharos, or a high voltage system from Osiris, up to advanced aerodynamics and structure. And in this brain integration role, ATR leads HERACLES to ensure that all the technologies that are developed across the different projects are consistent with one another, are compatible with our aircraft level architecture, and in the end, all these technologies are assessed to understand what is their impact on the performance, the emission, the safety, and the operability. Last but not least, HERACLES also connects projects from the different clean aviation calls, past, present, and future, that together will form the regional pillar of the clean aviation program to ensure that all these projects progress as a coherent whole towards a realistic aircraft concept in the end.
Sounds very promising. Thanks for that. HERACLES is largely about testing a very large and a new type of regional aircraft. How is it different from how airplanes are usually designed and tested?
I would say that the key difference here is that we are operating a largely uncharted territory. Hybrid electric regional aviation has enormous potential, and we know that. But many open question remains around the performance, around safety, integration, and certification. And the role of HERACLES is actually to support the maturation of these technologies, to demonstrate that they are feasible, but not to launch an aircraft development program. Large-scale validation through component tests, system benches, ground integration, and finally flight demonstration, which is our cherry on the cake, is essential to prove that these technologies are viable and scalable. At the same time, we already consider what would be needed for a future development phase. That means that advancing not only the maturation of the technologies, but also the certification readiness and industrial maturity is a key for HERACLES project, so that in the end, the clean aviation results are genuinely exploitable. In the end, HERACLES bridges research and future development without replacing either.
Great. And how does Heracles ensure that the flight test airplane is not just technically viable and can fly, but also, in other words, becomes scalable towards certification and future entry into service?
I think that it all starts with the representativeness. Heracles, as the integrator, as the brain, if you prefer it, defines the validation criteria to ensure that the demonstrator is as close as possible to a realistic aircraft configuration. The goal is not just to prove the feasibility, but to reduce the gap between the demonstration and the future product. And by aligning validation, safety assessment, certification readiness, and impact evaluation, HERACLES ensures that each demonstration meaningfully de-risk the future decision. In short, it's about building demonstration that matters, not just for today research, but for tomorrow aircraft. And a side consideration is needed for the certification. We are actually closely working with the EASA, the European Aerospace Safety Agency, which is directly involved in both HERACLES and DEMETRA, as well as FARES and OSIRIS. These allow regulators to gain early insight into these new technologies while giving us continuous feedback on the certification readiness. And also in this matter, HERACLES plays a key coordinating role, ensuring that the lessons learned are shared consistently across all the related projects and that the certification considerations are addressed not just at the aircraft level, but also at the system and subsystem level. Rather than waiting for new rules to be written, this collaboration helps shape the future regulation approach based on real data from ground and flight testing. And this is actually the added value that we have in all the 4 projects.
That was very clear. Thank you. And finally, how does Heracles address cross-disciplinary coordination? So ensuring that lots of different parts effectively work together between propulsion, which acts as the heart, as we mentioned earlier, electrical architecture, which acts as the nerves, structural elements, and aircraft systems, so the whole body, within the broader clean aviation framework.
Yeah, indeed. I think this is probably the main challenge of the HERACLES project because the URA concept combines many innovation, more efficient thermal engine, new propeller, hybrid electric propulsion, high voltage electrical system, advanced airframe, and a large set of enabling aircraft systems such as avionics, autopilot. On their own, these technologies don't automatically deliver the full environmental benefit, the 30% that I was referring at the beginning. Their value comes from how they are combined and integrated. And HERACLES define the aircraft level requirement and cascade them to FARES, OSIRIS, and any other relevant project and partners to establish an integrated verification and validation plan across the regional pillar to ensure that each technology contributes effectively to the overall concept. Managing interfaces is a major part of this work. For example, to ensure that the propulsive system, which is studied under FARES, communicates efficiently with the electrical architecture that is studied under OSIRIS. And HERACLES is actually playing this role as integrator, because in the end, we do not want to optimize each system individually that may result in a sub-optimal solution in the end. We want to optimize how do they work all together.
Thanks a lot for giving us that excellent overview, Alessandro. We'll now move to Laure. Laura, could you tell us more about DEMETRA? Could you tell us how the project's main objective and how it contributes to the overall maturation of the ultra-efficient regional aircraft concept?
DEMETRA means demonstration of an electrified, modern, efficient transport regional aircraft. DEMETRA is really about taking hybrid electric aviation out of theory and putting it into the air. Its core objective is to demonstrate on a real aircraft, an ATR 72-600, that a hybrid electric power plant and the related systems can work together safely and efficiently at regional aircraft scale. What makes DEMETRA special is that it doesn't work in isolation. It sits at the heart of a broader family of clean aviation projects, as just said by Alessandro, that together form the ultra-efficient regional aircraft concept. These other projects are FARES, which develops the hybrid electric power plant itself, and OSIRIS, that focuses on the high-voltage electrical architecture needed to power it. DEMETRA is where those technologies finally come together on an aircraft. We integrate them, test them on the ground, and ultimately fly them. The results will directly feed HERACLES. So you can think of DEMETRA as the experimental proof and HERACLES as the architect that uses that proof to design the aircraft of tomorrow. For this demonstration, we choose the ATR 72-600 as a flying test platform. It's an aircraft that we know extremely well, and it represents exactly the kind of regional operations where the hybrid electric technologies can bring real environmental benefits. Alongside the flight test, DEMETRA also includes extensive ground-based demonstration, from wind tunnel testing to optimize propellers, to full system benches where we validate new control logics like single lever power management. All of this is about reducing uncertainty prior to the future aircraft's development phase.
Laura, when you're doing something as new as using electricity to help power a plane, what would you say are the biggest technical risks that you have to solve before you can even think about flight testing?
Indeed, we identify two critical areas: high voltage and energy storage, the batteries. Hybrid electric propulsion requires voltage levels that are far higher than what aircraft are traditionally designed for. Managing high voltage safely, including insulation, fall detection, and failure containment, is therefore a major focus we will work on. The second key challenge is battery integration, especially when batteries are installed in the cabin, and that's the case. The batteries must meet extremely demanding safety requirements, notably in terms of thermal runaway prevention and containment. That drives very stringent specification, which impact weight, architecture, and integration choices. In DEMETRA, we mitigate this risk by doing as much testing as possible on the ground before flight. For example, the entire electrical architecture is validated on dedicated test benches, allowing us to observe behavior, failure modes, and interactions in a controlled environment. Clean aviation also enables close collaboration with battery manufacturers so that aircraft integrators and technology developers progress together rather than sequentially. That co-development approach is essential when exploring such new technologies.
There are definitely challenges that need to be looked at. Thank you for giving us that very useful overview. DEMETRA also focuses on ensuring that multiple advanced systems can operate together seamlessly at aircraft level. So, what makes the integration at this scale particularly challenging for hybrid electric regional aircrafts?
Yes, integration is often where innovation really gets hard. And hybrid electric aircraft are a perfect example of that. We are not just adding one system to an existing aircraft. We are introducing an entirely new way of producing, distributing, and managing energy on board. That means electrical motor, high voltage networks, batteries, control software, all interacting with conventional aircraft systems that never designed for this. On top of that, that has never been done before on a regional aircraft of this size. The certification framework for hybrid electric propulsion is still being developed, so we don't yet have a long rulebook to rely on. That pushes us to be extremely rigorous in how we analyze interactions, define interfaces, and validate safety. In DEMETRA, we address this by putting a very strong emphasis on verification and validation. Every interface is clearly defined, every interaction assessed, and every assumption tested, first on the ground, then progressively at aircraft level. In that sense, DEMETRA is not just about making technology work together, but about learning how to integrate them in a way that could one day be certifiable and deployable in real operations.
Thanks for that. What would you say are the key milestones that you must achieve before the technologies can be considered ready for flight testing, Laura?
Yes, the path to flight demonstration is carefully staged. We start with a preliminary design review, where the overall configuration of the flight test aircraft is frozen. This is followed by a critical design review, which authorizes the manufacturing of the systems that will eventually fly. From there, the focus shifts to progressive integration and testing. Technologies are first integrated into dedicated ground test benches within projects like FARES and OSIRIS. Only once they have proven their behavior, we'll install them on the aircraft. An extensive aircraft level ground test campaign then verifies that all interfaces work as intended and support the preparation to the permit to fly. The final milestone is the first flight readiness review, where all stakeholders confirm that technical, safety, and regulatory conditions are met before taking to the air. Through this process, we track technology maturity using technology readiness levels, starting at Tier 4 in 2026, reaching Tier 5 after ground testing, and finally Tier 6 through flight test demonstration.
Thanks for taking us through the objectives and challenges. I think this is the last question for both of you, which is a personal question. What makes it exciting to work on such projects, assuming it is exciting, and what do you enjoy the most? We can start with you, Alessandro.
Yeah, thank you for the question. I know that you mentioned from a personal point of view, but allow me to start from an enterprise point of view. Because for ATR, leading such projects in a new European environment is a first. And even if we look at the Clean Aviation program itself, the way the four projects are intertwined and collaborate one with each other is a first and is a great achievement of the whole program. And to be in the first line in this kind of premiere for ATR is a great honor for me personally. And what motivates me in the end is that being here at the center as HERACLES coordinator, integrating inputs from each project, see the aircraft as a whole is something that is, allow me the expression, really cool. And I really look forward to seeing what will be the results 5 years ahead of the road.
What about you, Laura?
Personally, I'm very proud to be part of such a program and to coordinate this ambitious collaborative project called DEMETRA, which will enable the implementation of innovative technologies on regional aircrafts. I'm looking forward to seeing this demonstrator flying in the sky.
Thank you so much, both of you, for sharing a lot of great insight into these cool projects, as Alessandro said. And we are also looking forward to seeing this become reality. Thanks very much for joining us on this podcast.
Thank you.
Thank you.
Two projects with a common vision and commitment to redefining regional aviation, from validating hybrid electric architectures to solving the puzzle of system integration. HERACLES and DEMETRA remind us that the path to sustainable flight is built step by step, on the ground, in the lab, and eventually in the air. Thanks once again to our guests Alessandro and Laure for walking us through the milestones, challenges, and collaborative spirit driving these projects forward. If you enjoyed this episode, be sure to subscribe to Plain and Simple wherever you get your podcasts. You can also follow Clean Aviation on LinkedIn or visit our website at clean-aviation.eu to follow along on Europe's journey towards a sustainable aviation future. Until next time, keep your eyes on the skies.